So we will start from 5 exactly.
Hussein Khan. Sorry, Sasi.
Yes, sir.
We
Did you
will
ask me?
start from 5 only.
Yes, sir. Sharply we will start at 5, sir.
So it will be 5 to 7.
Yeah, 5 to 7, sir.
And VIT is organizing a number of workshops.
Yes, sir.
That list.
Yes, sir. It is there. Many of the department they are organizing as per their own.
VIT has Department of Statistics also probably. Or mathematics and statistics. I don't know.
Mathematics. It is there, sir.
Okay, okay.
But is Selvam,
Okay.
sir, do you know, sir, whether we have statistic department?
No, sir, only mathematics.
Only
Only
mathematics. Yes.
and here you have commerce as well as business administration or
Business.
management as a separate department.
Yes, sir. Management, business, they are separate, and we are under the School of Social Science and Humanities.
Okay, so
Sorry,
that
language.
that must be School of Management.
Yes.
VIT Business
Since
School, sir.
since I have been with the Management Institute for a longish period, 16 and a half year,
Jaipuria.
Jaipur Institute of Management. I joined in 2005 as senior lecturer,
Yes, sir.
professor in 2013, and then left in January 2022.
Yes. 2020, you have been there till
2022.
Hmm.
So
Sir, in VIT statistics faculty may be around 100, sir.
okay.
Good evening, sir.
Good evening.
Good evening, madam.
Good evening, Associate Dean, sir. Selvam, sir.
Thank you, madam. Good evening, madam.
Good evening,
Masood,
ma'am.
sir. Good evening, sir. Welcome,
Good
sir.
evening, ma'am. Good
Yes,
evening,
sir.
ma'am.
Ma'am is our HOD, sir.
Yes,
Yes.
Yes,
the title is HOD Department of Commerce.
yes,
Yes.
sir.
It is there. Right.
Lenny?
Dr. Vineet KM. Sir, Vineet, sir, you are from?
Yes, sir. I am from Government College, Tiruponthura, Kerala.
Oh, thank you. Welcome, sir.
Thank you, sir.
Which is department, sir?
The commerce itself.
Oh, super. Thank you.
Our dean sir also has joined, sir. Sir, good evening.
Yeah, very good evening. Very good evening.
Sir, good evening, sir. Selvam, sir.
Good evening, sir. Good evening, sir. Very good evening, Dr. Masood Siddiqui.
Good evening, Dr. Manoharan.
Very good evening.
Good evening, sir.
Good evening, ma'am.
How is the weather there at Vellore?
Yeah, I mean, today it's a little bit okay. It's about to rain, but it's cloudy.
Okay.
But anyway, it used to be very hot nowadays. By this time, the southwest monsoon is supposed to have started, but it is getting delayed.
So we are starting in 2 minutes, I suppose.
No issues, sir. Once it crosses 50, it will be fine.
I'm just joining in 1 minute.
No issues, no issues, Professor, please.
So, Dr. Mohsin, should we start?
Uh,
Or should we wait around 5 minutes?
no, so we will start. Dean sir, shall
Yeah, yes, sir. You need 5 minutes or?
No, I am okay, but at present 43.
Yeah, 44.
Yeah, 40.
Actually, 100 plus resistance are there.
So okay, we can wait around
Another 2-3 minutes.
3-4 minutes.
Yeah, fine.
That's no issue.
Motion sir, shall we start?
Yes, ma'am, we can.
Yes, sir.
Jintu is there.
Yes, sir. Shall we start, sir?
Yes, please.
Yes.
So, good evening, all. Welcome to our second day of 7-day workshop on enhancing research skills in social sciences and languages. I request Dr. Manoharan M. D. School of Social Sciences and Languages to give felicitation address. Sir.
Thank you, Dr. Jintu. Very good evening to one and all. Once again, I send warm greetings and welcome to everyone who are present here for the second day of the 7-day workshop on enhancing research skills in social sciences and humanities. So the participation is very overwhelming. There are 100 plus registrants are there, and we do have registrations from across the country, and we have resource persons also from all over the country. Today it's going to be the second day, and the second day is going to be on full of statistics, fundamentals of statistics, and introduction to SPSS, importing data, and other. So any quality research requires quality data, and quality data need to be analyzed and interpreted in a rightful way. So the numbers will tell many stories than the scripted one and all. So today we have with us a man of numbers, we can say, Dr. Masood Siddiqui, professor and the Department of Statistics University of Lucknow. Sir, thank you for accepting our invitation, and thanks for
Thank you.
joining this session, and thank you for being a resource person for today, and as well as tomorrow, and as well as it's going to be a day after also. You are going to be there for 3 days. Irrespective of your busy schedule, you have accepted to be the resource person for this 7-day workshop.
Thank you.
I should appreciate. Welcome, sir. Welcome, sir. Thank you
Thank
for
you.
your gesture. I appreciate our organizers, Dr. Moshin, Dr. Jintu, Dr. Geeta, and our associate in Selvam for opening in the galaxy of resource persons, the eminent and authoritative people in the respective domain. So these kind of things will facilitate the knowledge sharing at a very high level. So it's a good initiative, and I'm really thankful to them. So today this session will be there on foundations of statistics. I do believe all the participants will have a fantastic session ahead today. So once again, I extend my warm welcome and greetings on behalf of Vellore Institute of Technology, School of Social Sciences and Languages, to the resource person, Dr. Masood Siddiqui, Professor and Head Department of Statistics, University of Lucknow, and also Associate Dean, Dr. Selvam, Head of the Department, Dr. Geeta, and Dr. Moshin Khan, Dr. Jintu, and all the participants from all over the place within the country, and research scholars of VIT and other eminent institutions. Once again, I welcome you. Even though it is a Sunday, the participation is highly encouraging and overwhelming. Nearly we are reaching 70% of the registrations. So in terms of percentage, it is encouraging. So thank you once again to the organizers. So I wish this event fantastic one. So thank you, one and all. So what do you, ma'am?
Okay, thank you so much, sir. So now I request Gida, Dr. Gida R, to give a brief introduction to our resource person, Dr. Masood Siddiqui. Ma'am.
Very good evening. Thank you, Jintu ma'am. Thank you, Dean sir, for giving the warm welcome. It is my immense pleasure to introduce to our esteemed resource person for today's workshop. Dr. Masood Siddiqui is a professor and head of the Department of Statistics, University of Lucknow. Previously, he served as a Dean Research, Pan Area Chair, Decision Science and Analytics, etc. at Jaipur Institute of Management, Lucknow. So he has been associated with great learning also. He has PhD in Mathematical Statistics and was a CSIR UGC Fellow in Mathematical Sciences. His area of expertise is machine learning, analytics, data sciences, econometrics, multivariate data analysis, decision modeling, automation, research methodology, etc. He has wide experience of consulting and also has taken more than 350 FDP, MDP in various areas. He has co-authored the famous book Statistics for Management, Pearson publication. He has more than 50 research papers to his cited in various internationally acclaimed journals and has more than 600 Google Scholars citations, including 12 H-index, 12 I-10 indexes on today. 3 Indian patents have been granted, published to him this year. Today, we are fortunate to have Dr. Masood here with us to share their expertise, insight, and practical wisdom. Sir, your presence will undoubtedly enrich our learning experience and inspire us to reach new heights in our respective endeavors. Please join me in extending a warm welcome to Dr. Masood as we eagerly awaited their individual contribution to our workshop. Thank you so much, sir, for being with us today, and we are going to enrich our knowledge by your experience sharing.
Thank you.
Thanks a lot. Over to Chintu ma'am.
Okay, so now we'll start our section, sir. Siddiqui, sir, you can start. Sir.
Okay.
Thank you so much. Sir.
First of all, thank you, VIT. Thank you, Manoran sir. Thank you, sir. Thank you, Geeta ma'am and Jintu ma'am. And thank you, Dr. Mohsin, for inviting me to the sessions. And good evening, all the participants. Remember, we all belong to the domain of education. So we are imparting education. So in that way, we are on the same platform. It is just a matter of chance that I am on the other side. So this is primarily the sessions involving the faculty members as well as the research scholars. So our main focus is towards enhancing our research skill. So whenever you face any issue or anything that is to be explained again, kindly do indicate me through the chat. Chat is open. Otherwise, we will have we will take problems and queries towards the end also. So that there will be both way. And moreover, here I am sharing some slides, so they will be shared with you after the session. So don't worry about noting down everything. The main important thing with any software is not how we run the software. It is actually developing a concept that how it would be useful for our purpose. And definitely, I will be taking cases in all my sessions, and that cases may belong to a particular domain. Because there must be some background, there must be some reference for the cases. So don't worry about the domain that is being used in that cases. These techniques are applicable everywhere. And one thing more, since I am using the dual screen, so whenever there is some issue with the sharing, kindly indicate that there is some problem. So here I am starting with a case, then we will discuss the concept. So this is the case, or let me share this case, just a moment. I suppose let me share this case through the chat, if chat option is there.
Yes, sir, it is there.
Okay, just a moment. But how it can be shared?
Sir, chat box, you can go and
Chat
share.
is there, but probably unlike Zoom, there is no option of sharing. Okay, so I will be shared later on. Is that okay?
Okay, sir. Even sir, you can share to me. I can share this one through WhatsApp.
Okay. So just okay. So, or I will share later on, right?
Okay,
Is that
fine,
okay?
fine, sir.
Because in the system, I'm not opening the WhatsApp. Anyway, I will share later on. This is a simple case. Not much is there. And for somewhat detailed cases, they will be shared later on. Just a moment. So this is the case. Case is there. Ventura sales reporting. Hello.
Yes, sir.
Okay. Right. Let me read the case. This case is related to a FMCG company, which sells a range of the product. It has 1150 sales executives, or they represent 1150 different outlets. So whether we say sales executive or we say outlets, they both represent the same thing. And a sample of 60 sales executive or outlets were chosen, and information is collected from these 60 sales executives only, right? So remember the first concept, that we have data from only 60 of the outlet out of 1150. means we don't have complete information. And this is a typical situation with all our research setting, all the cases, whatever the domain is. We will we will never have the complete information. So in statistics, we say this type of information as information from the sample. And this information is being collected on 6 variables or 6 features. The first one is the location. There are 4 locations: northern, eastern, western, and southern. Then we have 2 type of outlets, whether that belongs to the urban outlet and the rural outlet. And these are the 4 sales figure for the first quarter, second quarter, third quarter, and the fourth quarter. So this is the data that we are going to use for our discussion. Right? So this is a normal case, and here I will be introducing the data later on. So for that purpose, let me discuss the concept. Then I will be coming back to this case. Okay. So the topic that I have written here is exploratory data analysis. This is the broad topic. Right? Let me discuss a situation that whenever we meet a new person, whenever we meet a stranger, right? Means that is the first acquaintance with that. So whenever we meet, what our mind does, we screen our mind, screen that person. And this thing is very well evident when we see some science-fi movies that some extraterrestrial body or some machine comes on the earth. So the first thing that machine or the extraterrestrial body does whenever it encounter a unknown human, that it screen that person. So in the same way, whenever we meet a stranger or a person for the first time, our mind screen that. So here, this is the first acquaintance of a researcher with the data. Right? So whenever we see the data first time, what we do as a researcher, the same thing that our mind does, we screen the data. So that is known as data screening. Just like in the case of human or some machine, for the first acquaintance, what is the objective of that data screen? We examine the quality of that person, right? Whether that person looks to be acceptable, that person looks to be compatible. If that person looks to be acceptable or compatible, we may smile at that person, or we uh, we are ready to know that person somewhat more. But whenever that person doesn't looks to be compatible, doesn't looks to be good, we normally avoid that person. So the same thing occurs here also. Whenever there is some data, what we do, we examine the quality of that person, and simultaneously with the quality, with the examination of the quality, like our mind does, we try to have some basic understanding of the data or basic understanding of that person, right? We want to know some basic understanding of that person or basic understanding of the data. So whether it happens in our life or it happens as a researcher, both things remains the same. And this basic understanding is actually known as, we want to describe that person or we want to describe the data. Okay, so these are the things that we do under data screening. And since this is the first acquaintance of the data, so the examination of the quality as well as the basic understanding is actually exploratory in nature. So this is known as exploratory data analysis. So this is a topic that we are going to cover. So here, one important, the exploratory is clear. This is our first acquaintance. And the important word that is there is the data. So why data is so important, right? So data is actually related to numerical information, right? So it is actually the information that we try to examine, right? Because this information in its present form, it contains everything related to that situation, but not directly useful. So, so that's why this is known as raw data. It happens in our real life also. Whenever we meet any person for the first time, we might not have the complete information. So it contains everything, but not directly useful. Right? So what we try to do, we try to process this information so to make it useful. So obviously making it useful is for a particular purpose. So this is the information that is being put in the form of numbers. So since with the advent of analytics and with the advent of software, it is there that everything is to be converted into the numbers so that can be examined in a better way. Now this data can be in the form of structured format. Structured format is normally in the format of a data frame. Right? Whether we follow the Excel format or we follow the SPSS format or any other format also, it is in the form of this cross tabular form or this bivariate form. Normally we have on this vertical side we have variables or the features on which information is collected. And on the row side, we have cases or samples where we collect for a number of people. So this type of data is known as structured data. We may not always have structured data. Data may be unstructured format also. So the first thing to make it compatible for the analysis, even for the exploratory data analysis, we convert unstructured data into the structured data. Now, our data can be in the three format. If we collect data for a particular point of time, so for a particular point of time, the collected data is known as cross-sectional data. Like the data that I have just introduced is actually a cross-sectional data because it has been collected for a particular point of time. The time series data is the data that is arranged as per the time element. So that can be in the form of, even the present case has a tinge of time series data also. Suppose we collect production for January 2022, Feb 2022, and so on. So this is known as time series data and the longitudinal data. Panel data is the combination of both cross-sectional as well as time series data. So data can be in this format also. Now, all the data that has been collected is to be put in the form of numbers, but number doesn't mean that it is measuring something. So if the data is measurable, is in the measurable form, that is known as metric data. Like the sales, like in the case that I have just introduced, the sales figure, height, or the risk index or the return. This is known as metric data. And the other one is the non-metric data, which is actually the categorical data. Like here we have used rural versus urban. So we may put the numbers 1 for the urban and number 2 for the rural. So here numbers are there. But that is not measuring something, that is actually representing something. So this is known as non-metric data. So this is the basic differentiation. Now for a researcher, we should be very familiar with the scaling concept also, because the tool that we decide depends upon the scale that we use. Here the most elementary being among the scale category is the nominal scale, where numbers are used for the nomenclature purpose. Like here we have put 1 for the urban and 2 for the rural, or we put 1 for the northern, 2 for the eastern, and so on. So that is known as nominal scale or the categorical scale. This is in the most elementary form. So it contains only the name. And after that, if we put the order also in the form of rank, so that is known as ordinal data. So these first two category of data does not measure anything. So they are known as non-metric data. So the tools that we will discuss in due course, we will be using, we will be considering them as non-metric data. After that, we have interval scale data and the ratio scale data. These are the measurable data that is something is being measured. So here interval data, where actually in the interval scale, it has three characteristics. It puts the name, it also has the order, and it also have the difference also. Difference means the difference between 1 and 2 and the difference between 2 and 3 will always remain same when we use this interval scale. And the last one is the ratio scale, which has naming, which has name, which has order also, which has constant difference, as well as which has ratio property also. Means the ratio of 4:1 is always the 4 time, or ratio between 4 and 2 is always 2:1. So this is the ratio scale data. So these two scale belongs to the measurable case. As we move forward, I will be introducing all these scales in a bit a comprehensive manner also. And before moving to the analysis part, whether exploratory or the confirmatory part, what is the objective of the data analysis? Since it contains some information, it contains some meaning, but not directly useful. So as a researcher, what we do, we try to draw meaningful information from large mass of the data. So this is the data analysis. And one thing is important, meaningful, different people may have different requirement, they have different meaning. So it depends upon number of features that is expected from the analysis. So that's why we always say as a researcher, just a moment. We always say as a researcher that this is not an isolated activity. Any analysis is a function of objective. If objective is different, the analytical tool or analysis may be different. It also depends upon the research questions and the hypotheses that are derived from the objectives. So objective governs research questions and the research or the hypothesis, and in turn, it also has some impact upon the analysis also. Which type of sampling scheme we have employed, what are the measurement and scale techniques that we have used. Obviously, the tools that we use for the nominal scale may be different if we use the ratio scale. Like for the nominal scale, which is not measuring anything, for the central tendency, we use more. And whenever we measuring something, then obviously we can go for the mean or etc. Right? So whatever the measurement and scaling technique we are employing has some implication on the data analysis also. And finally, how the data is being collected. So all these features have some implications on the type of analysis we do. So what is the objective of putting that point? It is important that all these things come under the broad category of the research design. So for any research design is very important, because if we haven't given much focus on the research design, then obviously what we can do or what we expect from the analysis might not be there if some previous steps are not being taken care of in a detailed manner. So this is just the broad introduction of the data and what we are going to do here. So any question up to this point? Remember, we haven't yet entered the exploratory data analysis. So this is just a broad or overall view, high level view related to the data analysis. So any question up to this point? Or should we move forward?
Yes, sir. You can go ahead, sir.
Okay. So before moving forward, let me introduce the software that we will be using. This is SPSS. It is from IBM, and the full name is Statistical Package for the Social Sciences. So obviously tools belongs to the statistics, but actually it is developed for the social scientists. It is not typically for the statistician purpose. So my objective of saying this is it is much easier to use the software, right? So don't worry about that. Even if you have no familiarity with this software, it is much easy and anyone can develop the concept here. So in order to explain all these concepts, let me take up a case. Let me take up the software, and through that I will be explaining these concepts again. So this is the typical screen whenever we open the software, that is SPSS. So this part, it is much similar to the Excel, but having some difference. So this part is exactly similar to the sheet that we use in Excel. We have variables or the features on the vertical side, and cases or the samples are on the horizontal side or the row side. Now, unlike Excel, it has two tabs. So this tab is known as data view, where the data is being filled. And there is an addition that is known as variable view. So in Excel, we simply put the numbers, but we cannot explain what those numbers represent. So for that purpose, SPSS has provided one more tab that is known as variable view. Suppose you are putting data, right? So suppose the first variable is gender. Just a moment. First variable is gender. So the name of the variable is being put as gender. So here, this is the name. This name requires certain rules that are to be followed, certain conventions that are to be followed. Right? I will be introducing those in due course. So this is the gender. Just a moment. Right? This is a gender. So once we enter the this variable name, other things are being highlighted. Now this label is just a description of the name whenever some description is required. So obviously here label is not required. So we have put gender, only the name is there. Right? And the default type of the variable is numeric. Right? If you click on the right corner, so there are three buttons. So we can change the variable type also, but in default, we use the numeric form only for the analysis. But you can change this to string, you can convert it to the scientific notation and so on. Anyway, we are using the numeric form. Width and the number of decimals, they are not much of the use, so I am not discussing. Right? Label I have introduced. I will be putting another variable so that you can differentiate what is the difference between the name and the label. Then we have value. Since gender is not, suppose we are considering two genders only, right? So gender 1 is suppose female and gender 2 is the male. So now we have to explain that 1 represents female and 2 represents male. So that can be done through this value label. So you go to the right side and you click to the right corner. So there are three buttons, and this is the dialog box that is known as value label. Now you can define the codes that you are using. So 1 representing female, so it has been added, and 2 represent the male. It had also been added. So see, remember they are in the form of quote and unquote. So whatever you write here would be displayed in the output. If we write only male, if we write only F or M, so they will be displayed. So here we have written male and female. These are the codes. So whenever in this variable, whenever there is 1 that represents male, and whenever there is female, and whenever there is 2 that represent the male. And now we come to the missing, means if some information is not there, we are not putting anything. So the empty cell is being treated as the missing. This is the column weight. This is the alignment we are not discussing. And then finally we come to the measure. So here scales are there. So here actually 3 scales are being mentioned. One is the nominal, other one is the ordinal, and for interval and ratio only scale word is used, because all the tools that are there for the ratio scale are also there for the interval scale also. So there is a common thing, that is scale. Now this variable is nominal in nature, so we have put the measure as the nominal. So this is the first variable. Now the second variable is monthly income. Okay? Let me write monthly income. Here I have put the gap, means we have put a white space. And this white space is not allowed. So if we try to put that variable, what is the warning? That variable name contains an illegal character. So only hash is allowed here. no white space, no gaps, and no other things are there. So that's why there are certain rules that are to be followed when we put the name. So here we put only income, right? Now this income is not very clear whether this is a monthly income or this is an annual income, or whether this income is in exact form or this income is in the form of thousand of rupees. So here we define the label as monthly income. Label is just the description of the name, and it can be written in any form. Like here I have put the gap also. So this is a monthly income. Here you can write in the form of in rupees or in thousand of rupees. Anything can be written. Okay, so this income. So this is acceptable. So you can write anything in the label, but not everything is there in the name. So whenever name and label are there, then the output would be in the form of label only. And whenever obviously only name is there, then the output would be in the form of name only. And since this is on the ratio scale, so we put this as a scale variable, right? So this is name and gender, right? So since two variables are being entered here, so now these two variables are being shown on the data view. And here I can enter. Suppose the first one is a male, so this is 2. His monthly income is 55,000. So we can write 55,000, right? The second one is a female, so we can enter 1, right? And her monthly income is 60,000. Okay. And here the next one is again a male, and his monthly income is 70,000. This data has been entered. If you convert this into the value label form, so all the codes that you have developed would be displayed in the gender, like 2 represent male and 1 represent female. Okay, and you can check here from here also. Once you go to the right side and click, it is showing 1 as female and 2 as male. So in this way, the data can be entered. So this is the thing where we directly try to enter the data into the SPSS sheet. But always it is being recommended that you should put the data in Excel because it is easier to carry. It can be opened in any system, whether SPSS is there or not. But normally all the systems have Excel. So it is better to put the data in the Excel, and that data would be imported inside the SPSS that I will be introducing later on. So any question up to this point, or is that okay? Any question? Anything you like to make it clear? Is that okay?
Yes, sir.
Okay. Yes, sir. So now I will be showing the sheet that will be imported here. Right? This is the Excel sheet. I will be sharing it later on. It is related to the a class.
Excuse me, sir. Sorry for the interruption, sir. There is some
Yes.
question in chat box.
Okay. Just a moment. Let me check. Okay. How to enter open-ended question here. Now here, since you want to enter the open-ended questions here, which is in the form of I statement. So for that purpose, let me show you, right? Suppose the next variable is here. And the next variable is here, opinion. Now, this variable should be in the form of, just a moment. It is not numeric. So here you can put the string option. Okay. And you can increase the character to 28 or 29. Or any high number of characters, suppose 50. Okay. So now you can write anything here. When you go to the opinion, like you can write NNN, right? Or SSS and so on. Is that okay? But obviously here, SPSS is a quantitative software, so it cannot analyze any string data or any open-ended question. So there are different software whenever we use open-ended question. Is that okay? Okay, right. So now I am coming back to this sheet, right? And I am showing you, this is an Excel sheet that is there related to a class, right? In the class, there are 50 students and 6 features or 6 variables are being considered. The first one being their gender, then 10th and 12th score, then their graduation score, then the graduation stream, then the entrance examination score, right? So it is the class that has just enter a management institution or any engineering college, right? So this is the score, and we want to import this to a SPSS sheet, right? So how this Excel sheet is being imported into SPSS? Remember here, since we want that variables should also be imported in the SPSS sheet, so the only thing of caution is all the names of the variables should be put only in the first row. Like here, means whatever the width or whatever the length of the first row is there, it is immaterial, but the name of the variables are being put in the first row only. So this is we are putting the names of the variable in the first row only. Remember, this is the data set that we are importing. Since the file is to be imported and we cannot import an open file, so I am closing down this file. And now I am importing this. So we go to the file, and here, since already a file is there, we are not going for a new file. So from the file drop menu, we go to the open, and then we go to the data. Now this is the this is the location where we are having this file. Okay, right? But here that Excel file is not visible here because by default it opens the SPSS statistics or .sav file only. So we change the file type to XLS or XLS, right? So now this is the file that we are discussing. So this is the case academic data and we are importing. So we are selecting this and we open this, right? So this is the dialog box. The first thing is here the location is there, the folder that we have used, that is the VIT June 23, and this is the file name, right? It has only one worksheet, so only one worksheet is there. But if our file is having more than one worksheet, so you can always change the worksheet or you can select a particular range only. And this is the thing that we are discussing, that read variable name from the first row only. So directly variable names are being picked from the first row only. So it is for read variable name from the first row, and it will be showing you this format that on being imported, this will be the view of the SPSS sheet that we are going to create, and then we press OK. So now, right, like here you see the data have been imported, right? It is up to case 55 and all these variables are there. And it has also created the name as well as labels are there. Okay, but now you can always explain the values that is being used here, like gender, one for the boys or the male, right? And 2 for females or the girls. Now you can define the nominal skill that is being there. And as you see here, by the logic of the data, it has put gender as well as graduation stream in the nominal category only, and all other features in the form of scale only. So by this manner, we can import a data set from Excel to SPSS. So any question up to this point? Okay, there was one more question. What about yes or no type question? So So if we put the answers as yes or no, obviously they are in the form of string. So it is better to develop the value labels. Like here I am showing you. Suppose we again have opinion underscore one. Okay? So this is opinion related to something. Now here you can put one as yes, and normally we put no for zero, right? That I will be dealing when I will be teaching the logistic regression also, and we put zero for no. So this is zero for no and one for yes, right? So here you can write the opinion as, suppose the first one is saying no, so it is zero. The second one is saying yes. This is no, zero. This is again yes. This is one. Right? So now in this form, you can put yes and no also in your data sheet. So this is again the nominal scale. So here opinion one is the nominal form. Okay. So in this way, we can always enter yes or no in our questionnaire. Yes. Next question. Someone has raised a hand. Yes, Miss Subramanian. Any question? So Miss Sangeeta, is it okay?
Yes, sir. Thank you.
Okay. And someone has raised the hand also. So what's the question is?
I think there is no question, it seems.
Okay, okay, no issue, right? Right. So,
Sir, some question has come.
acha, okay. So if okay, age is asked as an open-ended question. Okay, right. Let me explain that. Just a moment. Suppose here we have age. And we want to put them in the category. Suppose the first category is 0 to 25. Okay. The second category is 25 to 30. The next category is 30 to 50. And the next category is greater than 50. Right? And here we can have the codes like 1, 2, 3, 4. Right? So in that way, in that manner, we can convert the age into the code form. Is that okay? One more thing, right? Suppose the data has been collected and we want to convert them into the categorical form. So for that purpose, either we do in the Excel by using if and else option, and there is one method in SPSS also, where we can always put the data in the form of this category only, right? So I, Ms. Thomas, is it okay? I will be showing the second form through the SPSS. Let me show that first, right? Then I will be coming back. Okay. So suppose we want to convert this entrance examination percentile into 2 or 3 category, right? Uh, suppose we want to segregate all who have less than 75 and all who have more than 75. So how that can be done? So for that purpose, I will be going to transform, right? Then we go, um, there are two methods. One is compute variable and other one is record into different variable, right? Suppose we use record into the different variables. So we select entrance examination and we put the new name as entrance category. Okay? We put entrance category, right? And we change this. Then we click old and new. Now here, we can make use of the range also, right? Like for the range, we can put 0 to 74.9, right, as 1, okay, and 75 to 100 as 2. Okay? And we continue, and if we press OK. So as you see, a new variable has been created. So all those scores which are less than 75 are being coded as 1, and all those scores who are more than 75 or more are being coded as 2. So you can easily define how many categories are there by through this manner. Is that okay? Any other question? Yes, it is not necessary that the category the class interval would be same. It actually depends upon our research. Suppose we are considering the income, and we want to focus on a particular category like middle income category, right? So we can put 0 to 20 in 1, 20 to 25 2, 25 to 33, 30 to 35 or 36 4, and then 30 to 50 at. So it is not necessary that all categories are having equal interval, and obviously you can convert any category to any form of the code, like the question from Miss Shruti. Is that okay?
Thank you, sir. It's okay.
So, is that okay? So we move forward. Okay. Can I am repeating that again. Right here. Let me delete this. Suppose we want to convert entrance examination scores into 2 or 3 categories. Suppose 3 categories. We go to transform, right? Then we go to record into different variable. If we use record into the same variable, then the original variable would be erased. So the rule is never ever touch the original variable, right? Always go for some extra variable. Okay, just a moment. An important call is there. Just a moment. Okay, so I'm sorry. I'm just repeating that again. Right. Suppose we want to convert them into 3 categories. So we go to transform. As I have mentioned, that normally we avoid using record into the same variable, because in that case the original variable would be replaced by a new variable. That not a good thing. So we always recommend record into different variable. Okay. So now just we go to transform, then we go to record into different variables, and this is the variable that we that are to be recorded. And here we put the new variable as entrance exam category. Right. Now we define old and new values. Suppose the first category is 0 to 70. So we select range.
Sir,
and
the
we
screen is not visible, sir.
okay, just a moment. It is there.
Yes, sir. Not
Yes, sir.
Okay, so let me explain that again. We go to transform, then go to record into different variables. Okay, and we reset, and we select the variable that is to be recorded, that is the entrance examination score. And we put the new variable name as entrance category. Now we click old and new values. So to define the values of what values are to be converted. So we select old and new values, right? Now we come to the range. Suppose the first range is 0 to 70. Right? So we select 0 to 70 at the first range. And for this, we are using the category code as 1. So all the score 0 to 70 is being put as 1. The next one is 70.01 to 85. It is being put as 2. Then is 80, more than 85 means 85.01 to 100. And here the value is 3. So all these values are being converted. You can check up to 71, 70 to 85, 2, and if we have, and more than 85 is 3. Is that okay? Is that okay, class? Right.
Yes,
Yes,
sir.
sir.
Right. So should we move forward?
Sure, sir.
Right. So here, in this manner, we can always develop a new category or convert the range to any form. It can be done through Excel using if and else option, and it can be through SPSS also, like the manner I have told you. Right. So this is the basic introduction of importing the data. So let me show you the part that we have covered so far. So here I have introduced SPSS, I have introduced data view, variable view, right? So importing the data or entering the data manually. We have defined name, labels, everything is there. And saving the file is just the is exactly similar like the Excel thing. And the link would be .sab. Right? Here we are having the screenshot. That can be just a reminder how that can be done. So I have put the whatever we discuss in the form of screenshot also. That would be useful when you are revising the concept. Now we are coming to exploratory data analysis. As we have discussed that it is the part that is related to data screening. And through this, we are having a broad view of the data. That in that manner, we are actually performing environmental reading. And there are two objectives. One is to describe or to summarize the large mass of the data. And the second is related to data examination. Data examination is for quality check. Means data should be of good quality. Otherwise, garbage in is garbage out. Right? And these two things go hand in hand. Like that is related to examining the quality of data. That is also known as data wrangling or data munging. So the objective is examining data before applying analytical technique. Right? So we will be having basic understanding of the data and the relationship among variables and ensuring that data have everything that is required for an analysis, means ensuring the data underlying the analysis meeting all the requirements are there. So that's why this is known as investment in the data analysis. Means to extract the good quality of the data. Otherwise, it is garbage in and the garbage out. And this aspect is also known as data preparation. And if data is not of the good quality, this I will be demonstrating, we will be purifying the data and cleaning the data. So to make data quality good. Okay, so here we will be discussing what we are going to do. And simultaneously, we are also discussing the various tools that we will be using to describe the data, or the descriptive statistics tool. The objective is to summarize the large mass of the data. Now we will discuss some basic characteristics. Since this data is being collected for some objective, since this data is being collected for some objective, so data must have similarity aspect. Like here, we are having 100 plus participants, so there is similarity. What is the similarity? That all of us are learning some statistical tool for the data analysis. All of us are attending a workshop or FTP. So there is some similarity. So whenever there is a data, there must be some similarity. And this similarity is also known as general tendency or overall tendency or the central tendency of the data. So this similarity is being measured by measures of central tendency like mean, median, mode, and so on. So whenever we collect data, whenever we consider the data, it must have similarity. So it has a basic characteristics, a default characteristics that data must be similar in nature. Now, along with similarity, there is dissimilarity also. Since anything cannot be a clone, here also, along with the similarity, there is dissimilarity also. We belong to the different domain, right? We belong to the different part of the country. So along with similarity, there is dissimilarity also. And this similarity provides us information that is inherent in this data. And this dissimilarity is being measured by dispersion, that is range, quartile range, variance, and standard deviation. So these two are the basic characteristics of any data. Means data must have similarity as well as dissimilarity also. And there are two other things also that is related to the shape of the distribution that will be discussed in due course, that is related to skewness and the kurtosis. So these are some basic tools that we are using in order to describe the data. And these tools are applicable whenever we examine the data quality also. So here I am taking the case that I have just introduced that is related to the Ventura sales, and through this case I am explaining all these concepts. Okay, so now I am opening up my main file, that is a Ventura sales data. I will be sharing that file by the evening. So we are opening this and we are closing down the other files that okay. So this is our data set that I have discussed in the start. It has 6 variables: location, type, Q1, quarter 1 sale, quarter 2 sales, and quarter 3 sales. Location and the type, these two variables are nominal in nature, right? Remember, for the location, 1 represent the northern, 2 represent eastern, 3 represent western, and 4 represent southern. And here 1 represent urban and 2 represents oral. And these are the ratio scale data. So this is the data set that we are going to consider. Remember the case, we have to prepare a comprehensive sales report for Ventura. But the issue is we have data only from 60 outlets, not from the entire 1150 outlet. So from these 60 outlets, we try to have an idea about the sales that is there in Ventura. So these are the variables. Now, the first tool that I have introduced through the slides is the descriptive statistics tool. So remember, earlier I have introduced transform, that is used for transforming the variable and so on. Now, all the analytical tools that are there in the SPSS are under analyze. So under analyze, all these tools are there. So whatever tools we are using is there under analyze. And here we are discussing the descriptive statistics tools, means the statistical tools that are used for description of the data. Now, here there are three major tools that are used for the descriptive statistics purpose. Most elementary being descriptive and most detailed being explore. Right? So I am introducing you these tools. Though we can directly use the explore because it is very comprehensive, it contains everything that we require. But just to make you a bit ease or a bit familiar with the software, I am introducing the most elementary one, that is a descriptive. If we click descriptive, so this is the typical dialog box whenever some analysis is being desired through SPSS. So in this dialog box, all the variables that are there on the data sheet on the SPSS are in the left block, right? So all the variables are there, and the variables for which some analysis is to be run should be transferred to the right. You can transfer one by one, and you can transfer more than one also. Suppose we want to examine sales of the outlet of the first quarter and sales of the outlet of the second quarter. So we transform them to the right block. So the output would be there only that will be related to these two variables only. You can select one by one, you can select all of them. Now, if we click the option button, right? So some tools or some options are being checked by the default manner, means they will be there. You can delete that also. Suppose you don't want mean, you can delete that. Otherwise, mean is there. You can increase also, like you can increase skewness, you can also increase kurtosis, right? So you can add something, you can remove something also. Since we have moved from the dialog box to the sub dialog box of the option, and we want to go back to our main dialog box, we click continue. If we click continue, this is again there. And if we press OK, right? So this is the output. Right? Now we are discussing this output. So is that okay? Any question? Is that okay? Any question? Okay. Right. So now, here, let us discuss the columns for which output is there. Like in the first column, we have valid observation at 60 and sample size is also 60. So what do we mean by the valid observation? Sometimes we collect data. Suppose we have collected data from the 60 outlet. So it may be possible that all the outlets or all the sales executive may not report everything, right? So in spite of taking a sample of 60, we have valid observation of less than 60 also. So the remaining observations are known as missing observations. Like here, the sample size is 60. Suppose we don't have information from the 10 outlet. So the valid N would be 50 only. So this 10 would be the missing observation. This missing observation play a role for generalization of the data, because we are considering 60 as a good sample size, but actually the data which is there for the analysis is much below than 60. So the volume of the missing observation play a role related to quality of the data that we'll be discussing later on. Right? So one thing is there. The next is minimum. Minimum means values start from this value and this is the maximum. And then we have mean statistics. Like here we have 81 and 72. Right? Now mean means average value for the outlet in the first quarter. This is 81,000, and average value of the sale of the outlet in the second quarter is 74. So if we look for this data, it appears that Ventura was performing very good in the first quarter, but not performing that much good in the second quarter, right? Isn't it? If we compare this 81 and 72, right? Now, here the role of the quality of data comes in a big way, right? That whether this 81 is a representative measure or not, right? So this we will be discussing, right? And through this case, I will be introducing why data quality examination is so important. So before discussing that, let me explain some concept. Then I will be coming back to this output again. Okay. So here, we are discussing what aspects are required when we examine quality of the data. So first is the missing data, means where we don't have the information. So missing data that I have just explained, and when valued value of on one or more variable is not available, right? So this type of data is known as missing data. What is the impact? What is the role of the missing observation? It may have impact upon the generalization. Generalization means some type of inference, because we are analyzing sample, and through this analysis we are making opinion upon the entire group, that is known as population, because all the policies of the company or everything that is being thought of is for the population. So here what is the issue? That we are analyzing a part of the population, a sample only, and through, because we don't have the complete data set, and through this analysis we are making opinion upon the population. So it has impact on generalization, right? So there are two concerns actually. One is the volume of the missing observation, is how prevalent the missing data is. The second is the pattern or the relationship of the missing observation. So if volume is high, then obviously this is the issue of concern. But even if the volume is not high, but there is a constant pattern, like here, suppose we have all the missing observations are there that have come from the eastern location. Means there is some issue with the eastern location, because eastern location outlets are not providing the data. So obviously if we make policy for the eastern region also, so that should be a misnomer, because there is less representation from the eastern region, right? So there must, means it might be possible that volume of missing data is not that much high, but there is a consistent pattern or there is a defined pattern, so that should also be noted, right? So now if we have the missing observation, so what can be done? So one method is the complete case analysis, that is known as list-wise approach. Here all the missing data cases are deleted. Means even if among the 6 variables that I have introduced, only one observation is missing, the entire case, entire cell is being deleted. So here all the missing data cases are being deleted. So now what is the issue with this? If we do this, there will be a major loss of the data. And what is the benefit? That we are considering only that cases which are all valid in all the aspects. So effectiveness wise that is okay, but problem is we are majorly losing the data. So what is the another approach? Another approach is we take all available approach, pairwise approach. Suppose we are examining Q1 and Q2 sales. So it is immaterial whether there is some missing in Q3, Q4 or so on, right? So here we will be having less data loss. But the generalization might not be good, because we are taking up a case which is not complete in all aspects. So it may pose some problem in the future. Now, so here we are just deleting. We are actually removing the missing observation. Another way is imputation technique, missing value imputation. Means we can replace the missing observation by a particular representative thing. Now, what that can be representative thing? We replace it by mean. Suppose here I don't know about a particular participant, right? Suppose I don't know about Priyam, right? But since the basic or the basic characteristics or general tendency of the participants are, they are either research scholars or they are the faculty members. So I can easily presume that Priyam must be a faculty member or a research scholar, right? So this is known as replacement by a representative measure. We can replace by mean or we can replace by the median, as the case may be. I will be explaining. And if we are considering the time series data, then we can replace the missing observation by linear trend or interpolation. So this is known as imputation technique. I will be showing how that can be used. But there's a big question. Decision should be taken whether to use imputation or not. Right? Let us take a case. Suppose 30% are the missing observation. So the question arises, what needs to be done? One thing is, we can remove these 30% missing observation. So what is the problem here? There will be a major data loss. Means we are analyzing only 70% of the observation. So there is some merit with the removal, but there is some demerit also. So what other things can be done? We can try imputation. Means we replace this 30% observation by mean. Now what is the issue? Now there won't be any data loss, but now these 30% observation would be exactly similar. Means they become clone. Since they become clone, so there is a major loss in the variability. Right? And remember, variability is very important for any analysis because it contains the information. So we are deliberating, compromising on the variability. So what is the objective of introducing all these things? Because all of us are involved in some type of research. So my point is, there is no definite answer what can be done. Right? If you remove this 30% observation, there will be an impact on the data loss. But if we impute, then there are issues related to losing the variability in the data. So the bottom line is, there is no absolute truth in the analysis. In some situation, some approach may be there. In some other situation, some other approach is to be there. So it lot depends upon the researcher, which approach the researcher adopts. Right? So this is about the missing observation. So any question? I will be showing how imputation can be done. So up to this point, any question? Okay, so now I am using the imputation. Right. Suppose we are having missing observation in the Q1 cell. So how that can be done? We go to transform, and in the transform drop menu, we have replace missing values, right? So we choose this option, that is replace missing value, and we select the variable that sales of the outlet in the first quarter, right? And here, as you see, one more variable has been created, that is Q1 sale underscore 1. Means it is not touching the original variable, it is creating a new variable. And here the missing observation can be replaced by series mean. It can be replaced by mean of the nearby point, median of the nearby point. We can use interpolation or linear trend. Is that okay? Right? Anyway, we are just replacing it by the series mean. So if we do this, as you see, a new variable has been created. where all the missing observation are being replaced by the series mean, right? Obviously, there is no missing observation in this data because this data is being made for the demonstration purpose. So here that is not required. But in this manner, you can create a new variable that takes care of missing observation. So in this manner, you can go for data imputation. Okay. Related to interpolation, interpolation means when the change is inside the series. And extrapolation means when change is outside the series. Suppose the next figure is missing, that is known as extrapolation. Okay, so interpolation means inside the series, like in the time series, where some observation is missing, and from the first to in between, from first to the last thing. So that is the interpolation. Is that okay? Okay, right. So this is related to imputation. Now I am introducing one more concept, then I will be coming back to the case. So we have discussed the missing data. And another thing is that is related to outliers, right? Outliers means standing outside. Means a value that is distinctly different from the others, standing out from the others. This is known as outlier. Right? Let me take a situation. Suppose one batsman is to be considered for IPL team based upon his batting performance. And data is there for the last 10 innings, and 10 innings are capable enough to decide whether that batsman is doing good or not. His scores are like this. This is 0, 0, 5, 5, 0, 300, 4, 6, 0, 0. Okay, this is the score. And if we calculate the mean of this batsman, it comes out to be 32. Right? The mean is 32. Right? So suppose it is being reported that the average score of this batsman is 32. So what is the expectation of the team management from that batsman? If that batsman goes to bat, that batsman will be scoring 32. Now, whether this expectation is reasonable or not? Obviously not. So if you look for this data, the general or the overall tendency of the batsman is to score a very low score. The batsman is scoring single digit runs in the 9 innings out of 10. So we can say that this batsman is not a good batsman as far as batting is concerned, and he is a low scorer batsman. But because of this value, that is the 300 value, it is giving the impression of a good batsman with an inning average of 32, right? So now let us discuss about this 300. Obviously, this 300 does not belong to the overall tendency of the data. So this 300 is different from overall tendency or the general tendency of that batsman. Okay, so this is an outlier. This is known as an outlier. So outlier can be an high value, outlier can be a low value also. Like some batsman is scoring this. And here 0 becomes an outlier for this batsman because it does not belong to the overall tendency. So the major question arises whether we should be putting that outlier or not, right? So obviously if we put that outlier, there is a big impact upon the mean. And if we remove the outlier, there will be a data loss, but now the average would be the real one, right? So always there is a question whether to include that score or not. So this is known as outliers, right? And here I will be introducing through the software how that outlier can be recognized or can be find out. So the presence of outliers also have impact upon the quality of the data. Is that okay? Any question up to this point? Or should we move to the SPSS part? Yes, someone has raised hand. Kindly ask or write on the chat. Any question? Okay. So now here I have introduced the descriptive. Let me select the other one. We go to analyze, then we go to descriptive statistic, then we go to the most detailed one, that is explore. So this is the dialog box of the explore. Here again I am taking the two variables, sales of the outlet in the first quarter and sales of the outlet in the second quarter. And these variables are transferred to the right side for the analysis purpose. Now here we have descriptive, all the descriptive tools are there. We can introduce outliers also. We can introduce M estimators also. Here M estimators are the robust estimators that are used whenever our data has some outliers, right? So they are represent the general tendency. We can use percentile also. And related to the plots, right? Like stem and leaf is there, we will be introducing histogram. And soon after, one more checking is there, that is the normality, whether data is following normality or not. So we are introducing this option also, that is normality plots with the test. Okay, so here all the options are there, and then we press OK. Right. So this is the explore summary. I have discussed the missing observation. Now let us discuss this block, that is the descriptive part. Now, as in the first quarter, mean is 81.18, right? Median is 71. Median is the middlemost value. So obviously outliers have impact on the mean, but outliers does not have impact upon the median because median is the middlemost value. So if we find the major difference between mean and median, it is representative of the presence of the outlier, right? Because outliers have impact upon the mean only. If outliers are on the higher side, then mean would increase. If outliers are on the lower side, mean would decrease. But if we consider the second quarter, mean is 72 and median is 73, very close. So there is no major difference between mean and median. Again, if we compare mean with 5% trimmed mean, 5% trimmed mean, we know that trimming is always done on the edges, right? So 5% trimmed mean means 5% lower values and 5% upper values are being trimmed, are being deleted. So this average is based upon the middle 90% of the observation. Obviously, if our data contains outliers, so it will be on that edges only. So 5% trimmed mean also takes care of the outlier. It deletes the outlier. It means if there is a major difference between mean and 5% trimmed mean or mean and median, it is indicative of the presence of outlier. So in the first quarter, there are indications that outliers are there. Now in the second quarter, mean is 72.4, 5% trim mean is 72.4, median is 73. All three values are very close. So in the second quarter, we does not have outlier. Even related to M estimators also, right? M estimators, I have told you, they are the robust estimators. They are least affected by the outliers, right? So as you see here, in the first quarter, all values are indicating 72, right? And it is much closer to 5% trim mean and the median and much far from the mean. So all these measures suggest that there are outliers in the first quarter. and we can check it here also. Like these are the outliers options results. SPSS provide us top 5 and bottom 5 values for each variable. Like in the first quarter, highest value is 61, which is there on the case 55. Next value is 90, next value is 88, next value is 88, next value is 87. So as you can see, this 611, which is there at the case number 55, is widely different from other values, right? Now we come to the lower side. The lowest value is 54. The next value is 57, 57, 58, 58. Not much of the difference. So outliers are not there. In the second quarter also, the highest value is 92. Next value is 90, 89, 86, right? So here it is clear that our first quarter is having an outlier, that is 611, right? And we can check here also, like if we go to the case 55, this is case number 55, it has a value 611, which is actually some error if we see the other values, right? So what is the recommendation? Either we delete this case 55 or we improve this value. So actually it happens because of some overwriting or overtyping. Actual value was 61 and it has been wrongly entered at 61, right? So here, if we go with this 61, the results are badly impacted. So this is the role of an outlier. So any question? Any question? We have discussed two aspects, one related to missing value, other related to outlier. And simultaneously, I am also discussing the various descriptive statistics tools. Is that okay? Should we move forward? Okay, right. Now the next aspect that we are going to discuss is, that is, a number of tools require the assumption of normality. Normality means the data distribution should follow normal distribution. Normal distribution means data can be expressed as a bell-shaped curve. Obviously, in the real life, exact bell shape is not possible. So that's why we will discuss various representative measures. So this is a normal data. So if our data is normal, then mean and median are approximately equal. In the same way, skewness, which represent the lack of symmetricity, it also zero. Right? It is a highly symmetric data. Right? So here we will be examining how normality can be done. So one is these things are there. The same concept is there related to this frequency curve or the histogram. So if we consider the histogram, so it will also represent the bell shape. So if histogram is broadly resemble the bell-shaped curve, right? It represents that our data is normal. Stem and leaf, like this histogram is a vertical diagram. This stem and leaf is horizontal in nature, right? So if we rotate this curve to the horizontal part, means like in this manner, right? It represents our data is normal in nature. Right? Box plot I will be introducing later on. Normal PP plot I will be showing you through the SPSS. It is always there. And simultaneously I am introducing two tests also. Though we will be discussing this statistical test in a more detailed manner tomorrow, but just for the introduction purpose, we have two tests are there. One is Kolmogorov-Smirnov test and the Shapiro-Wilks test. They are used to test the goodness of fit of data distribution. Right? So what do we mean by test? Though I will be discussing in a detail tomorrow. This test is when we want to have an assertion or declaration about the population, but we have data or evidence from sample only, right? So this is known as statistical inference, and for that test, for that purpose, we perform a statistical test. And for statistical test, we require a hypothesis, which is a conjecture, declaration, or positive declaration. There are actually two hypotheses. One is H0, that is known as null hypothesis, and this hypothesis is tested, to be tested. And it is tested against an alternative that is known as H1. Okay, right? So here H0 is data is normally distributed. So whether we use Kolmogorov-Smirnov test or we use Shapiro-Wilks test, always we take the null hypothesis, or it is there, it is the default null hypothesis, because the word null means it assumes no difference. Or in other words, it is to be nullified. So no difference means null, or it is assumed to be nullified, that is the null. Okay, so this is the null hypothesis. So all the tests are being made on the null hypothesis. I am not going into detail. Now there are different type of approaches. One is that we have studied through our books, right? In the earlier cases when we don't have software. So in that case, we compare the value that is being calculated from the test statistics or the formula, and we compare that with the value from the table. And another approach is using the p-value concept. This p-value concept is there. And the concept is here, if we have a small p-value, if we have a small p-value means there are rare chances of accepting the hypothesis. Means rare chances of happening such an event. Rare chances of happening of such a thing. So obviously, if there are rare chances of happening such a thing, we are not going to accept that. So it means if p-value is small, we reject H0. Okay. Now the question arises, what do we mean by small? So normally all these tests is being done at a level of significance. Normally we go with 5% level of significance. So if our p-value, that is also being written as SIG, is small, that is less than 0.05, we reject H0. Otherwise, we don't reject H0, right? Okay, so this is the obviously I'm not going in the detail because that requires a time. So we can discuss at any point of time. So if this is the case, then we can say that our p value is small. So we can say that normality is not there. Right? So I will be showing you through the output. So any question up to this point? Anything that is not clear to you?
Sir,
Yes.
for social science researchers, is the level of significance to be kept as 5%? If
No, no,
so,
no, no, no. No, one thing. This is the normal default level, right? It depends upon a number of situations, right? Whether we should go with the small p value or a big p value, right? Since you have asked, so instead of tomorrow, I am explaining this here uh, by taking an example. Right? Just a moment. Actually, whenever we perform the test, there are two type of law. Now I'm explaining the testing procedure. And here we are discussing errors in testing. There are situations. There are two situations. H naught is true and H naught is false. Obviously, if H naught is false, H1 is there. And there are two actions. We accept H naught and we reject H naught. Since everything is done on the H naught, we are considering. Now, if we consider these two blocks, here H naught is true, H naught is being accepted. This is the correct thing, no error. If H naught is false, H naught is rejected. This is again correct. Now, if we come to this block, right? Here, H naught is true, but it has been rejected. So, an error is being committed. And this is conventionally known as type 1 error. So what is type 1 error? This is reject H naught when H naught is true. Okay. And this is the another error. This is known as type 2 error. So what is a type 2 error? This is accept H naught, means we don't reject H naught when H naught is false. Now for a good testing procedure, we want these two errors to be as low as possible. So for that purpose, we measure them in the form of probability. So this is the first probability, that is alpha. Alpha is the probability of committing type 1 error. Probability of rejecting H naught when H naught is true. And the probability of committing type 2 error is being denoted as type 2 error. Now, we actually want to reduce both alpha and beta, but it is not possible. So what we do? We fix alpha. Alpha is being fixed. So what is the logical thing? If type 1 error is critical, we fix alpha at a low value. And we don't bother about beta. Beta may be high, right? Means if alpha is low, then beta would automatically be high. If alpha is high, then automatically beta can be low. So if type 1 error is critical, fix alpha at a low value. In the same way, if type 2 error is critical, then we are more concerned about the beta. We want beta to be less. Since we want beta to be less, so we fix alpha at a high value. Now, how can we decide? Now, let us take a case, a very common case. Case is, there's a case in front of a judicial body, so to decide whether that person is guilty or not. Means a person has come before a judge. Now, what null hypothesis is there? As per our legal system, the null hypothesis is person is innocent. Okay. And H1 is person is a criminal, not an innocent. Okay. Now, what is type 1 error? Type 1 error is reject H0 when H0 is true. Means court is rejecting innocence of a person when actually a person is innocent. Means what is the implication? An innocent person is being put as criminal, is being sentenced, is being punished. Isn't it? And what about type 2 error? Type 2 error is accept H0 when H0 is false. Means the court has accepted the innocent, but actually the person is criminal. Means since court has accepted the innocence, so a criminal is being set free. Obviously, both errors are there. Whether we consider type 1 error, when innocent person is being sentenced, is being punished, and in the type 2 error, a criminal is being set free. Okay, but as per our judicial system, as per the Anglo-judicial system, this error is critical. So if this is a scenario, we should put alpha as a low value. Means instead of 5, we can also consider 1%. And in some situation, type 2 error is critical, then we can put alpha as a high value, like 10%, 15%, or even 20%. Is that okay? So this is not fixed, but it depends upon the situation.
Thank you, sir.
Okay. Any other question? Neetu has raised the hand. Is it okay? Any question? Okay. So now I am coming back to the SPSS sheet so to explain the remaining part. Now we are discussing about the normality part. Like here, if we consider the histogram, if we consider sale of the outlet of the second quarter, and if we try to draw a curve, this is approximately normal in nature, right? So you can say that this is approximately normal, right? There are other diagrams also, like here. This is known as normal probability plot or normal quantile plot. As you see in this diagram, this graph, on the x-axis we have observed values, and on the y-axis is if the distribution is normal, then what value we are expecting. So if our data distribution is actually normal, then these two values would be same. Means if this value is 50, this is exactly similar to the value corresponding to expected normal. So it means all the points would lie on this 45-degree line. Means if the points lie on the 45-degree line, it shows that our data distribution is normal. So here, as you see, This is a 45-degree line, and most of the points are lying very close to this 45-degree line. So we can say that our data for the second quarter is normal in nature. But if we consider the first quarter data, this is a normal QQ plot. This is a 45-degree line, but here points are much deviated from this 45-degree line. So we can say that data is not normal if we consider the first quarter. And remember, it is happening because of presence of that outlier only. Right? Now, instead of this, if we consider test of normality through Kolmogorov-Smirnov test and Shapiro-Wills test. So if you look for the p-value for the first quarter, both the p-values are 0.000, here also 0.000. These values are well below 0.05, so we reject H0 of distribution being normal. So we can say that sales of the outlet in the first quarter is not normal, right? Because here we are showing the low p-value. But if we go to the second quarter, the p-value is 0.200, that is 20%, much higher as compared to 5%. And here the value is for the Shapiro-Wills test, the p-value is 0.489, which is greater than 0.05. So we can say that we are not rejecting the H0, that distribution is not normal. We are accepting the null hypothesis that distribution is normal. So the first quarter we are having non-normal data, and for the second quarter we are having the normal data. Remember, for the first quarter it is happening just because of presence of that outlier. So if you correct that value and rerun the analysis, like if we rerun this for only the first quarter, now the values are being corrected. So if we do this, now you can check the mean has been now 72, which is very close to 5% trimmed mean or the median. And this is a normal QQ plot. Now you can see all the points, means most of the points are there on this 45-degree line. So because of the presence of outlier, even the normality has been compromised. So that's why checking the quality of the data, having a broad characteristics of the data through this tool, it is important to check all these things. So any question up to this point? Any question? Related to normality or presence of outlier, or what can be done if the situation is there? Yes, any question?
Sir, can you tell about the sample size that is feasible for PhD thesis?
Okay. Right. So that I am taking. So up to this point, suppose there is no question. Now I am discussing one more thing that is a part of the statistical inference, but let me take up here only. That is, what is the required size of the sample. So I am changing my now I am discussing sample size determination. Here the most popular concept is the Cochrane formula. Actually, the sample size determination based upon two aspects. Number one, variability present in the data. So higher the variability, larger is the sample size. Because we want the sample to be representative. If everything is same, everything is clone, then if we study only one, then that is sufficient for the entire sample. So one is the variability present in the data. The second is level of confidence that we want to place in our results. Level of confidence that we want to place in our results. And the third one is degree of error allowed. So for this variability, we consider sigma. Sigma is the standard deviation. Level of confidence is dependent upon alpha or 1 minus alpha into 100%. Means if alpha is 5%, then we have 95% confidence. And degree of error is actually E, which is the difference between sample values, difference population values. So if we here, suppose we consider mean. So this is the formula, that is Z alpha, that is X bar minus mu sigma upon root n. So this is E, this is sigma upon root n. So from here we have E as, this would be sigma Z alpha upon E whole square. Right? Suppose Z alpha, if we consider 95%, so value of the Z alpha would be 0.96. This is for 95%. If we go for the 99% confidence, then this value is 2.58. So 1 Z alpha is clear. Suppose E we want as 5% error or 1% error. So value of E would be 0.05. Sigma, we have an idea about sigma through the previous research or through the sample. And if we put the values here, we get the value for n. Right? That gives us the required sample size. So this is one concept. Another concept is relatively simpler when we use the Cochrane formula. So suppose in our data, this is much related to the questionnaire format. And here the formula is E divided by root PQ upon N. Right? So this is a formula where E represents the error and this PQ upon N. Right? Let us take the maximum value of PQ. Remember, Q is 1 minus P. So maximum value of PQ is 0.25 only. This is possible when P is 0.5 and Q is 0.5. Means you can never have value greater than 0.25. So maximum value of PQ is 0.25. Right? Suppose we require 95% confidence. So value of Z would be 1.96. And E is the standard, that is 0.05. So if we put these values here, so what is the value? That is 1.96. This is 0.05 divided by 0.25 upon N. And if we solve this formula a bit, so what the value we are getting, 1.96 divided by 0.05 into root 0.25. This is equals to root n. And if you solve this, you can get an approximate value of n, right, that comes as per the situation is. Suppose you want more confidence, then you can put the value of Z as 2.58, right? And if you don't want 5% error, you want further less error, you can go for 0.01. So everything is not absolute. It depends upon the purpose. These are the formula that can be used as a guiding point, so to decide the appropriate sample size. Is that okay? Is that okay, Ms. Priya?
Yes, sir. Thank you, sir.
Okay. I will be sharing all these things, so you can always practice that, or you can always consider that. Any other questions, since we have some more minutes?
Sir, can we use the published data?
Yes.
Yeah, like Yamini formula, small n equals to capital N in club divided by 1 plus
Yes.
capital N E
Right.
square. It is easier
Actually,
one.
we have a detailed qualitative concepts also, right?
Yeah.
So these are the standard. Otherwise, if some big researchers have used a particular sample size and they have find the appropriate values, and if there is not much change from that situation, you can go with that value also. So there are a number of qualitative aspects also when we consider the sample size determination.
Okay.
So these concepts are actually the simplistic form, right? Whenever we decide the sample size, then a number of things are there. And now the things are for the big data. So whenever you are considering the secondary data, obviously we have plenty of data. So actually these concepts are much related to when we go for the questionnaire research only.
Okay, sir. Thank you.
Any other question? Anything that is related to today's concept, because this is the base, right? Though it appears that it is not directly useful for our research, but I have just shown that a single value has destroyed the overall characteristics of the data. So it is very required that we should be very clear that our data has all the requisite characteristics for a good data set. Otherwise, in spite of using the best of the software and best of the concept, the results might not be there. That is termed as true. Any question? Anything you like to discuss? Hopefully none. So, Dr. Mohsin?
Yes, sir.
And I am having session tomorrow also. So if
Yes.
you people have some issue, you can ask again. And in the slides, you have my number as well as email ID. So in future also, you can discuss if you face any problem in the research.
Yes. Okay, sir. Thank you. Uh, First of all, I would like to express our gratitude to all the participants who are attending the session today. Your active engagement, thoughtful contribution, and eagerness to learn have created an atmosphere over here. Now, I would like to thank our resource person, Professor Dr. Masood Siddiqui. Thank you, sir, for the session we had today on the fundamental of statistics. Your insights and guidance for the SPSS, data view, variable view, entering data, exploratory data analysis, and others also were incredibly helpful in clarifying the basics concept that we need to understand. So thank you so much for the session, and we are also excited to listen you tomorrow for the next content what we had. So thank you all of you. Thank you, sir.
Okay. Thank you.
Thank you. Thank you, sir.
Thank you. So we will be meeting tomorrow at 5.
Yes.
Kindly join by the time. So we will be starting tomorrow because we will have a big session tomorrow. All parametric tests as well as non-parametric tests.
So, sir, tomorrow for tomorrow's session, are you sharing some data
Yes,
set?
yes. I will be sharing with you, right? I won't be sharing PPT forehand, right? But the data set I will be sharing.
Okay.
Data set and the case. And PPT after the session because I am writing something on that. So that
Yes.
would be better.
Okay, sir. Fine, sir.
Thank you.
Sir. Thank you. Thank you, sir. Thank you, all of you. Thank you.
Thank you. I'm leaving. Thank you. Bye-bye.
Okay, sir. Thank you. Okay, sir. Bye, sir. Thank you, Dean, sir. Thank you, Salum, sir, and others.
Welcome, sir. Welcome, sir.
Okay, thank you, sir.
Thank you, sir.